We do have copies of our presentation being handed out by Doug. So I'd just like to start by introducing ourselves. I am from Sessions. We work on underground storage tanks. We do single wall tank inspections. We do lining repairs. We do double wall tank repairs. And we also do cathodic protection surveys and repairs. This Sessions was originally founded by James R. Sessions. That is my grandfather. He owned a gas station when the government began regulating underground storage tanks, and because he couldn't find anybody to keep his tanks in compliance, he started the business. It was then, when he retired, passed along to my dad, which is Ross Sessions, and I've worked there since 2009, and in the last several years I've learned quite a bit about underground storage tanks and the problems and perks and all that good stuff. So let me go ahead and introduce Tom.
Hi, I'm Tom Allen. I do special inspectors on coatings. I assess tanks for repairs, make recommendations on the repairs. I've actually been in the business for 30 years, doing nothing but tanks, above ground and underground. Basically, my primary thing is coatings inspections. I know that there's a lot of people out there who are not familiar with this process because we run into regulatory people all the time who's never seen it. So hopefully today we can clarify a lot of questions you may have about it. And if you feel free to ask us, anything we can, and we will do our very best to make it as clear of an answer to it as possibly can. Adam?
Well, good afternoon. I'm Adam Cottle, and I'm not really part of Sessions, but some jurisdictions require that a certified industrial hygienist be on site to kind of monitor the safety aspects of entering a tank, and whether it's a repair or we haven't done a lining in a million years, but a repair or an inspection that has to happen every 5 or 10 years depending. So I will meet these guys on a job site, and then, often I'll prepare a health and safety plan ahead of time that deals with, the CalOSHA aspects. Tom deals with the Title 23 aspects, and Jamie manages the project. But basically, I make sure that the tank work that they're going to do is handled safely. And sometimes it's really pretty exciting when, if you've never seen it, is when you see somebody start welding on a gasoline tank. That's really exciting. I'm pretty used to it now, and I still keep my guard up. But that's what I do, and these guys are pretty good. They really know what they're doing. I don't really have many issues with them, so it's a pretty good group to work with. And if you showed up to visit us on our tank work, this is what you'd see. You see the green barrel, and to the left of the green barrel, that is what we call an eductor. An eductor basically is drawing air out of the tank. When we first show up, I'll talk a little bit later about air monitoring, which is what I do. There's a lot of vapors in the tank, even if it's been triple washed, even if it's just totally clean. If we welded on a tank, I say we, I don't weld, but if we welded on a tank yesterday, that means it was really pretty darn clean. If we come back the next day to do some additional work on the tank, we'll put this eductor on and start ventilating again. The vapors overnight would have increased. We would actually have a flammable atmosphere in that tank on the next day when we were welding on it yesterday. So that's pretty exciting. It's something to think about. But this eductor is run by compressed air, and it has a capacity of about 875 cubic feet per minute. And on a typical 10,000 gallon tank, we get about 40 air changes an hour. So that's really considered pretty good. You get over about 4 air changes an hour, and the more you get over, the better. That means we're removing the vapors pretty well there. So there may be off-gassing, especially initially when it's still dirty. It hasn't been cleaned yet. That's what the sessions crew does. And then as it's being generated, the vapors are coming off, we're removing them. So that's what keeps it safe for us. Now, what you see above ground here goes up like 10 or 12 feet, and then there's usually a pipe that goes down to the bottom. And what that does is we want to actually collect the vapors that we're going to exhaust off the bottom of the tank. And we want to create turbulence. So when you see this eductor sticking up above, it's like a tree. The tree is above ground, the roots go down. We actually will suck off the bottom. And there'll be a manway open. You can't see it in this picture, perhaps. The next picture. And yeah, you see the ducts on the left there. That's actually blowing into it. And what we're doing there is we're actually blowing air into it and we're exhausting air out of it. So this is creating a lot of turbulence, a lot of mixing that we like. So we're actually, any vapors that get created, you know, there's always some, but we actually will do air monitoring, and I'll talk about that perhaps a little bit later. The lower explosive limit, if you're familiar with the LEL, we actually get down to non-detect on that. So that's what we really like. Diesel fuel is the process for diesel and gasoline is much the same, although in diesel fuel, it's always a lot better job from my perspective because the flammability danger is really quite a bit less. Okay, I'll turn it over to Jamie again. And I'm around for questions a little bit later, I think.
So once the tanks are ventilated, we physically enter the tanks. We prefer if the tanks have existing manways. It makes it a lot easier for the entry. We just unbolt the bolts around the manway, as you can see in the picture on the be on your right, and then we can enter the tank. A lot of times, though, you don't have a dedicated manway sump. So as you can see on your left, top left, there is that's a turbine and other fittings and connections. So we or a maintenance company would have to remove all those fittings, and then we would have access to the manway. Once the manway is open, then we just put the ladder down in there and we have access to the tank. A lot of times the human entry startles or scares people, but as Adam addressed, we take precautions to control the hazards that are there. A lot of times tanks don't have manways if they haven't been entered before. Most double-wall tanks, they aren't equipped with manways, so what we do is we cut them open. This is a single-wall tank, but it would be the same for a double-wall tank. We just cut the opening that we need, and we would either install a manway, or in this case, install a lid and then epoxy it on. We don't like to install the lids because they're not technically removable. I was actually told by Tom that they're a lot harder to remove than just cutting open the tank. But we prefer to install a manway and then a dedicated manway sump and a drive box in the concrete. Unfortunately, though, a lot of our customers don't like to opt for that because it is more costly. Adam, back to you.
Okay, so the big reason I'm out on these jobs is it's pretty hazardous work if it's not done properly. I liken it really to like baking a cake. If you don't follow the recipe, if you deviate from the recipe, it ain't gonna turn out right. And it's the same thing with what appears to be quite dangerous work. And let's face it, there are risks, and the risks never go away completely. The risk is not zero, but we follow established procedures. And one of the big things we look at is we treat it initially when we first make entry, we treat it as a permit required confined space. This is a designation from Cal OSHA. And if you're familiar at all with the Cal OSHA confined space standard, there's really two parts. There's 5157, Title 8 5157, which is the general industry standard, which is really a bit more conservative. There's also Title 8 5158, which is the construction standard. We go by the general industry standard. They're similar, but 5157 is a bit more restrictive. So what that means is when we first go into a tank, it's dirty. That's the most dangerous time from my perspective. And welding's dangerous too, but by then it's clean. But when we first go into a tank, sometimes the tanks are washed out ahead of time. A company shows up and triple washes them. They'll have like essentially a garden hose with some water, and they'll trickle it in there, and then they will vacuum it off. That's actually a good procedure. I actually like that because it makes it a little cleaner than it otherwise would have been for us. What we don't want, and we very much will not have, is if there's a pressure washing situation. Pressure washing creates static electricity, stirs up the muck. When you first pop a tank, the fuel is pumped off. There's going to be a little bit of a layer at the bottom, a little bit of sediment. And it looks sort of like when you're at the beach, that wet sand where the waves wash up. It looks kind of like that. You can have almost none to a few inches. So it just depends on how long the tank has been installed and how old it is. Older fuels were tended to be dirtier. I've been doing this kind of work for over 20 years, and the fuel in the last 20 years has gotten a lot cleaner, so we don't really see a lot of sediment in the last 20 years. But the idea there is that when we first go in, it's going to be dirty to some extent. And we go in, we treat it like a permit required confined space, which means we have a person hooked up with an extraction device and a harness and a lifeline, and we ventilate, and we do air monitoring to verify that it's okay to go in. And what does that mean? Basically, Cal OSHA says that there are 5 things that you have to look at, 5 hazards you look at when you have a confined space. One is, what we've done for a million years, is atmospheric hazards. So we look at oxygen, flammability, toxicity, in that order. And Cal OSHA has established what concentrations are considered acceptable. And we actually go with half of what the LEL requirement is. Cal OSHA allows us to go to 10%. We actually go up to about 5%. And the idea there is, if you can't get it down to 5%, there's something going on. We ventilate for a while. If we have to ventilate more than an hour or something like that, there's something going on there. That tank didn't get pumped off very well. We try to extract the sediment and any deposits of liquids in a low spot before we go in. We incrementally take on more risk. So like when Jamie was talking about cutting a hole in the tank, we don't just start off with a torch. That comes later, after it's clean. We do a rough cut with basically a pneumatic saw. So we incrementally take on more risk. So the thing is, really, from my perspective, that I'm really observant on, I'm observant all the time, but the observant on is, let's get this thing cleaned out. That's really what I want to do. And then after it's cleaned out, the permit required confined spaces really kind of go away, and it becomes what's called an alternate procedures confined space, which means that there's no other hazards besides potentially atmospheric hazards, oxygen problems, flammability, or toxicity. And then once we get get that to kind of go away with ventilation, and we verify it with monitoring. There's no electrical hazards, there's no mechanical hazards, no inwardly converging walls. That's an OSHA term, look it up. And there's no engulfment hazards. We never have really those other 4 hazards because we use lockout tagout procedures to isolate the electrical and the mechanical if there is any, and we bind off the lines. If there's an interconnection with other tanks, we plug that to make sure that we don't get some seepage from the neighboring tank. So then we get into the alternate procedures tank, and that basically what that gets us is we still ventilate, we still do monitoring, we still have a safety standby guy, OSHA calls it the attendant, and once it's cleaned out, it really becomes quite a bit different job. That's why in a little while you're going to see Tom modeling inside of a tank doing his inspection process, and he's not wearing a respirator or anything, and it's like, wow, what's that guy doing? It's perfectly fine. It's based on the conditions. Cal OSHA recognizes that the procedures that you need is based on the conditions. Cal OSHA also has a third category of confined spaces that we just never go there, and that's a non-permit space. A non-permit space means there's just nothing that can go wrong, and we never have those tanks. Even a clean tank, there's still going to be a little residual vapor seeping out of the pores of the tank the next day. So we never ever have a non-permit space, but we start off with permit required confined space procedures, and then we move to alternate procedures when it's appropriate. And that's really the standard way that we do this kind of work. The truth of the matter is, even initially when we first go in, by definition, it's still probably an alternate space, less hazardous space, because we have controlled all the hazards, electrical, mechanical, inwardly converging walls, engulfment, and the atmospheric hazard, we actually are controlling the ventilation, because otherwise we just don't go in. Okay.
So when we start working on a tank, we ventilate it, we'll gain access, and before we clean it, tanks are normally pretty dirty. Depending on what was stored there and when it was last cleaned, that sort of thing, we find varying degrees of dirty. As you can see here, this is what Adam was talking about, kind of the wet sand on a beach, sludge in the bottom of the tank. And he also mentioned that if there is any residual product in a tank, we would pump it out with an air diaphragm pump so that it's as empty as it can be so that we can clean it out. This tank is extremely dirty, as you can see. It was probably a diesel tank. Have you guys ever, when you're filling up your car with gas, noticed that the diesel nozzle is always extremely dirtier than the gas nozzles? You guys are a lively bunch. Well, if you've ever noticed, that's basically the same thing we see within the interior of tanks. Diesel is a lot greasier, oilier, and it's just a dirtier product. And so we see, when we see the inside of diesel tanks, they're typically a lot dirtier than gas tanks. So once we get all the fuel pumped out, we clean them. What we do is we take shovels and buckets. They shovel out any sludge like you've seen it in the previous pictures. They put it in the bucket, and then we have a tank attendant on the top of the tank. They'll pull it up with a rope, empty it into a 55-gallon drum or whatever the waste is being stored in, and send it back down. Once they get all of the residual product, the sediment, then they wipe the tank down with rags. When we were originally contacted to speak with you guys today, It was in regards to leaking double wall tanks, what we were finding, how we do it, etc. But a big part of our business is also the single wall tank inspections. And when we do those inspections, we basically take the same steps leading up to the inspection as we do when we're going in to repair or investigate a double wall tank. And it was brought to my attention recently that not all CUPA representatives or field inspectors have experience with single wall tank lining inspections. So I wanted to go ahead and take the opportunity to touch on that briefly. So before we start, or before Tom would do the actual lining inspection, we would ventilate the tank, access, clean it out, and then Tom would come in and do the inspection. So he's going to go over that inspection process with you and what tools and instruments he uses.
No, I don't. You just do it. Please. Hi. On doing the coatings inspections, there's really 4 aspects to it. Well, 5 if you count the visual. But the holiday tester, whenever you're holiday testing, holidays occur during the spray process. It's not something that occurs over a period of time. Those are pinholes that a lot of times are not even visible by your naked eye when the holiday detector will pick them up. Generally, by the time we're doing the inspections, we really don't encounter holidays for the simple reason why when they were initially lined, these same tests were done after the lining. This was prior to them having special coatings inspectors. This is when the contractor themselves did it. So the holiday detector, you'll go there, and again, it is to pick, you have about 35,000 volts that you're putting on there. The squeegee that's actually being run over the tank is where you got your power going to, and then you're grounded. If it goes over any place that is not insulated by the coating, it will make an arc, just like a spark plug or anything else. It'll be shooting a blue arc where it's grounding back to the tank. So, and you could even pull it away and go, and you can't see it, but it will pick up in the finest of the pinhole. So that's on the holiday testing. The primary thing in my doing it is the thickness of the tank. What do we still have there as a structure? So then we'll do the ultrasound. Well, oh, I'm sorry, I got out of line. This here is doing the dry film thickness, again, which is done whenever they do the coating. Most coating or linings at the time was done at 125 mils, so that's 1/8 of an inch. But whenever I go in there, I'm looking to see if they got at least an average of 100 mil thickness. Now, you really don't see any degrading or any of the film thickness thinning out because, number one, it's compatible with the product being stored. So, again, these are tests that were done by the lining contractors in the beginning, so these don't vary. If you have it today, you'll have it 10 years from now. Your thickness is going to be the same. Now, this, to me, is one of the ones that really need to pay attention to because on a single wall tank, of course, you have 2 different types of corrosion. You got internal and external. This is, so even though you got the inside protected, and of course, with cathodic protection for the external, how well is it working? Well, this is what it'll tell the story. So you can actually get the metal thickness reading through the coating also by ultrasound. And you need at least 75% of the original thickness for it to even be a candidate for even staying in service, because then you're starting to lose its structural integrity. You want to change it? Okay, here on the hardness test, again, these are done by the contractor when they're lined. It is to ensure that proper curing is going on there. We do it still on the inspections just to put to rest that the product being stored is not softening, gelling the lining material, which I've never encountered a situation where it has. So those are really on the deflection measurements, whenever you're doing a fiberglass tank, of course, ultrasound is of no use to you. You don't have a coating to holiday test or anything else like that. So your deflection measurements are what's really important as far as determining the stress the tank is under. Whenever you're measuring it, it can't be stressed out more than 1% of the circumference or radius of the tank. So when you go in there, you'll be doing your measurements, and again, these are measurements that the contractor will do once he installs them. So it's just the amount of stress that's being put on the tank, how much it's egging it, I guess you could say, if it's taking it out of its roundness. Like I said, tank manufacturers allow it to like 1%. And let's see, the single walls as opposed to the double walls, you know, we've been doing a lot of double walls lately, and the primary causes we find in them are all internal corrosions. And I would say 9 out of 10 tanks, they're diesel tanks that are having problems with this, the sulfur diesel, this new diesel to come up with, seems to be pretty corrosive. And where we find the corrosion at is right in the belly of the tank, right where all the sediment and what have you is laying. Diesel is bad about condensation, you know, making water. They're a very humid tank when you go in them. And if the tank owners don't have a good maintenance program on it, and I mean that by sticking them for water. Granted, the Vita roots or the ATGs, they do have a water float on them, but most of those are installed in the center of the tank, where tanks are installed with a tilt, the low end meaning to be on the fill end so you can extract the water being heavier than the fuel, you can get them out. But by the time that a Vita root, I'm going to use them for example, would detect water, and it being installed in the center of the tank, you have really got a lot of water in there by then for it to ever get to that float to float it up. Because, you know, on the low end of the tank, you know, you could literally have 10 inches, depending on how much a tilt is, before it would ever come up to the center of the tank to ever even float, the water float on the probe. So, and, you know, there's, and then of course there's different qualities of fuel out there. You know, where's the guy buying from? Is he just buying on the open market looking for the best deal? Well, he's probably buying tank bottoms that are somebody else's nasty muck. But anyhow, so they really need to have a good program on monitoring their fuel and stuff anyhow. And there's so many times, even though that the tank should be installed where the slope is, the low end is towards the fill, and of course your turbine is on the high end, these are designed to keep making sure that the customer doesn't get any water and stuff in their vehicles. But that's not always the case, especially on the single walls. Back then there were very few 4-inch or openings for them to plumb to. So therefore, whenever, as regulations changed and they had to reconfigure things, all of a sudden, let's say the fill's on the high end and maybe your turbine's on the low end. But the corrosion aspect of it is almost always right dead in the belly of the tank. And I mean, within like the first 2 or 3 feet from the very bottom going out. And you can generally, it'll be on the low end of the tank. This is where everything is just setting, and the internal corrosion is very obvious. I think Pete has witnessed that with us on there, and when you get in there, it's unmistakable. And on the double wall tank, you don't have electrolysis issues, so therefore, you know, it's all internal. If they actually, which I'm thankful they don't, but if the tank manufacturers actually were lining tanks and then selling them prior to them, would really pretty much put the tank thing to rest, because its only enemy is corrosion, or a bad installation, of course, but that's the only elements it has to deal with. So once the tank is lined, it's really basically bomb-proof. You know, you've taken away its only enemy, corrosion. And the diesel, I'm not really sure of all the aspects on why this new diesel is becoming so corrosive, but again, the majority of the tanks that we repair are diesel tanks. When you get in there, like I said, the internal corrosion is so evident. We've done them for tank manufacturers where they're still under warranty for them. That's how quickly a lot of them are being degraded. So it's the single wall aspects. I know that, again, I'm out there a lot, and there's so many people who haven't even seen this process, and it's, you know, it's understandable compared to what all else is going on out there. But we're really hoping today that we can clear up a lot of the questions that you guys may have on it, because I know that it's just something that the majority of you do not see. The single wall tanks, again, you know, you got the cathodic protection on it, which is very important they stay up on, because back when we were doing tanks and find them unrepairable or lining, at that point, most of it was external corrosion. But it all depends on soil conditions and what have you. But as long as they have a good active cathodic protection system on there and they're interior lined, the tanks look as good. Whenever I go into them, some of them 20 to 30 years ago that's been lined, looks as good as the day that I personally close up ones that I had lined 20 plus years ago. It's a very good system. About the only failure you really see in them is if there was a poor surface preparation when it was initially lined, the sandblasting. You will see releases. That is really about the only failure that I find out there. The cathodic seems to be working great on them, but you know, this industry's been very small from day one anyway, so there's not a whole lot of people who do it. But even in the heyday of it, there were so many people that was, like with any business, you got some that do quality work and you have others who don't. We've opened up tanks before we even go in them. It has released off the walls in such large pieces, you'd have to break them up to even get them out of there. And if anybody ever has an opportunity to look at a tank inside, the best time is after it's sandblasted. When they sandblast a tank, they call it white metal, but it's basically a light gray. After that, it'd be like putting a black spot on a white shirt. Anything in there is going to jump out at you. You can see it then. Because in the past, years ago, inspectors went into the tanks quite frequently. Now, the only ones I know of are Contra Costa County. But it's really an experience if you can go in there and actually see and the evidence of what's going on in them. It can give you so much more perspective on what you're regulating, you know. And I realize, you know, there's a lot of people who don't, and we try to provide pictures, videos, or whatever you guys may request for your training or what have you. But like I said, the biggest thing is as long as they're up on their cathodic protection, again, we're talking single wall tanks, and the coating things, there's very few. Generally, if I know who the contractor was who lined prior to me getting there, I can pretty much tell what to expect to see. There were some of them who did very poor surface preparation, and as you know, it doesn't matter what product you're using, if it's glue or whatever, they stress surface preparation. That's the biggest thing. And not to mention, it cleans the tank up to the point that it makes everything visible. There's so many times you can go in there, I've seen the times that I've gone to sites and they says they don't see any problem with the tanks, and I've gotten there and knowing what I'm looking for, and the tanks would be completely gone. It's like a rusted can. So sandblasting will really tell the story. You know, you can have a tank that's not leaking that actually has rust plugs within perforations that are not visible. But you sandblast it, it will open them up. The biggest thing is, again, it gives you a good clean surface and things will jump out at you if there's imperfections in there. Now, a lot of times when we open up tanks that we know are leaking, because you can't, I'm gonna get back to the double walls, that you can't get a vacuum on the annular space. Well, when tanks are manufactured, they're not butt welded in sections, they're lapped. So these lap seams are a catch-all for this muck and sediment that get up under there. So even though that you can't physically find a perforation, say, out in the middle of the tank, there generally are up under these lap seams because things become trapped. They're almost like little dams that go through there. Let's say on a 10,000 gallon tank, it's probably about the average size that you see out there. There's like 4 sections, and they're 8 to 10 feet long where the tanks are put together. And every one of these sections, there's a lap seam where they've overlapped them, and the tank is actually welded on the outside. So you can't actually see up under these to, you know, say, photograph a hole in the tank. But once you sandblast it, you get it dry, the pulverized media actually works as a wick. So anything that's leaked out, there is still moisture on the outside. It will pull it back, and you can generally identify it in that way. You know, it's like a powder or whatever. If there's moisture there, no matter how slight, it'll come out and you'll see a sweat mark or whatever, depending on how much is leaked out or where you're at. And other than that, I would say you guys, especially on diesel tanks, the double walls, you can expect them start being quite a bit of problems. We find it all the time, and the majority of them all are diesel. Every now and then a gas, but diesel's almost automatic. Whenever we get called for one, we can go, it's a diesel tank, huh? Absolutely. So, and that aspect of it, you guys can kind of start expecting them. Now, another question or thing that we've been having to deal with is compartment tanks. They share a common annular space, which in my opinion is really not a good design, because the manufacturer actually treats that as a single tank. We've just had 2 of these, and we did one in San Diego recently. So it's kind of hard to tell, okay, which one of the compartments are leaking, because you know you got product in your annular space, but it's seeing how it has a common one, where's it coming from? So many times that we've been directed, say, to one compartment or other as the suspect, and it not be that one. So you got to figure, even though you've got a compartment tank, and a lot of people see that as 2 tanks, well, if it's actually 2 tanks, they should have their own annular space, which you really don't find that. They usually have a common one. So you guys can expect with diesel tanks, you're going to start seeing more and more repairs having to be done or something being done with it. The internal corrosion is really kind of crazy in the short amount of time that I see it's doing it. Again, I've done some for modern that the tanks are only in the ground, say 2-3 years, and they already have been eaten through. So what they're going to do about it, what have you, I really don't know, other than having them repaired. So anything else about it on it? I hope that I've answered you guys' questions, and I'll be around if I can answer anything else and give you a card. Feel free to call me for anything if you may have a question about it. Thank you.
So just to kind of recap on the single wall tanks, we ventilate the tanks, we open them, we clean them. Tom will do his third-party inspection. Once that's done, we do the vacuum testing. The requirement on that per Title 23 is that it holds 5.3 inches of vacuum for at least 1 minute. And then that concludes it. The tanks either pass or fail, and all of the specific regulations on the passing and failing is written in Title 23. So let's move on to leaking double wall tanks. The process for ventilating, opening, and cleaning is all still the same as single wall tanks. We do a visual inspection to locate any perforations. A lot of times though, like Tom mentioned, the perforations aren't visible. As you can see in the left side, the corrosion, there's corrosion, but just because there's corrosion doesn't mean there's necessarily a perforation that goes all the way through the primary tank. And the other side of that coin is just because there's no corrosion doesn't mean there's not a perforation. So you can see there's corrosion in the left picture, and you can see where there's a wet spot from the breach in the seam in the right picture. So when we enter the tanks and we do a visual inspection to find the perforation, a lot of times it's not visible, so we do a soap test. It's what they do is they apply soap to where they would expect the perforation to be, and then we put air into the annular or interstitial space, and that creates positive pressure and it creates air bubbles. Sometimes that doesn't even work. We don't always know where we need to put the soap, and it's not practical to soap the entire inside of a tank. So if the soap test doesn't work, we go back to out of sequence and we sandblast the tank. I know we've had inspectors have issues with that in the past because typically we don't sandblast until we know where the problem is, and then we're preparing the tank to be repaired. But unfortunately, sometimes we do have to go out of sequence and sandblast first, and then, like Tom mentioned, that would it would be like a black stain on a white shirt. We would see it better. This soap test in particular would be indicative of a breach within the seam. You can't see it, but there's obviously a crack in there. That wouldn't produce very much fuel in the annular space, probably a few drops every so often. The degrees of corrosion that we see vary pretty heavily. As you can see here, those are pretty blatant holes, pretty obvious. Those would produce a much larger amount of fuel in the annular space. And in order to remove that fuel, we would basically do the same as the soap test. We would put air into the annular space, and when you do that, it would force the liquid back out through the holes that it came in. That would be another corroded hole that is obviously accompanied with quite a bit of rust and corrosion around it. And here is what some corrosion looks like after it's sandblasted. There have been a few tanks in the past that we've come across that, you know, it's leaking, their annular alarms are going off, they're getting small bits of fuel in the annular space, but we can't find a hole. We sandblasted it, we can't find any perforations.
While you're on that slide, may I make a comment? This is what I'm talking about in the belly of the tank, where you can see the internal corrosion. If you'll notice, when you go out, you see that the corrosion dissipates. You don't have it. This is directly in the belly of the tank. This is what we commonly see. And it's at different degrees as far as the depth of the corrosion. But as you come up the tank walls, that dissipates. I mean, you don't even see it. This is right where all your sediment, your water, what have you, is at. And most of the time, it'll be stacking more and more towards the low end of the tank. Seeing how this is out, let's say 18 inches. As you're coming to the high end of the tank, it'll start forming a cone. It's just less. I mean, you can just visually see right where the sediment stuff is setting. Earlier, did you guys see that little wet spot that was by that seam I was talking about? That's what I was talking about. Where they lap, you can't visibly see it under them because it's such a minute clearance. But again, that's where things get set up there and it just sits. And that's what I'm talking about the bleed back. So a lot of times that's your indication on where you have a problem. But the corrosion here you see is what we commonly see in the belly of the tank. And like I said, in these diesels, it's just more and more, and probably some of the deepest corrosion I've seen over such a short period of time. I'm sorry, go ahead.
Oh no, you're fine. Definitely feel free to interject. So basically there's been probably just a handful of occasions where the tank has been so corroded in certain areas, likely in the belly of the tank, that it's made the tank porous, and so it's allowed, even though there's not technically a perforation or a hole, the metal has become thin and porous enough that fuel leaks through. That would produce a very minute amount of fuel in the annular space, but obviously still enough to trigger alarms. And we would treat that thin area just as if it were a perforation, and we would patch it accordingly. So once we figure out where the perforation is, if we didn't need to sandblast to do that, we would sandblast the tank. As you can see here, just before and after pictures, how much cleaner and nicer it looks. Technically, we're not sandblasting, we're media or abrasive blasting. Sandblasting is the most common term and kind of the old school term, so, but we use some kind of...
We use slag. It's either a nickel or copper slag. It contains no silica, and it doesn't break up as it's much sharper. It cuts the impurities out of the metal much better. Because actually to apply a coating, you need like a 3 mil profile indentation of your metal so your liner can impregnate the metal and really adhere to it well. That's what I was talking about, surface preparation earlier. This is one area that you cannot scrimp or slack on, is that surface preparation. And as you can see on the right where the tank has been blasted, what I'm meaning by if there's something in there on a white shirt, it'll jump out at you, as opposed to the one that's on the left. Once the tank is blasted, it'll open up. The blasting process is actually pretty high pressure. It's pretty aggressive. So if you have thin spots that are not even opened up now, it will open them up. They have things that are called rust plugs, just with the sediment and stuff, that will actually keep product from going into your annular space. A lot of times after a tank test or something where there's been agitation going on in there, you may see them get washed out. But definitely after you sandblast, it will bring out anything that may be hidden. You will find it.
So once we find the perforations and we sandblast the tank, we do repair the perforations per Title 23's regulations. Is what we do is we use a fiberglass mat and lay that in combination with resin. And we use typically 4 layers. Sometimes if the corrosion is really bad, we'll use more than 4 layers of mat and resin combined. Once we patch the area that's corroded or perforated, we go ahead and do a vacuum test on the annular space before we fiberglass the bottom half of the tank and the seams, because it'll tell us if there's any more perforations in the tank. So when we vacuum, if we just patch the area that's corroded and we vacuum test and it doesn't pass, it'll either tell us, 1, that our repair patch is not successful, or 2, that there's another leak in the tank somewhere. And then once we, oops, wrong button, sorry. Once we patch the tank, then we apply fiberglass mat and resin to the entire bottom belly of the tank. And then once the fiberglass mat is finished, they resin coat the entire tank. So, having said all of that, when all of the work that we do inside of tanks is hazardous in ways, and we don't, very rarely are there extra people inside of tanks. So what we did is we simulated a repair on a pipe so that you guys can see exactly what we would do inside the tank. Let me see here. So I'm going to show you this video. Parts of it are a little bit slow and repetitive, but basically I wanted to show you exactly what we do inside the tank. So I hope this works out. There we go. As you can see, that's just the pipe that we use for simulation before anything was done to it. You can see it's pretty rusted and dirty. Can you guys see okay? Do the lights need to be dimmed at all? Good? Okay. Right there, they're just filling the sandblaster with the media that they use. You can see here that there's obviously a lot of dust and debris generated from the sandblasting. When they do that inside of a tank, it's constantly being ventilated.
And I will make a comment. As dusty as this seems, it's because of how rusty it is in there. Generally, you don't have that much surface rust over that large of an area, but of course, we were trying to simulate it. This is a piece of 4-foot pipe that's been outdoors for quite a while. Another reason we use a slag is it's not as dusty. So, seeing is everything down there. It's difficult to see when you're blasting anyhow. But as you can see, as rusty as that is, you'll see how white it'll appear afterwards. And it really just makes things pop that's in there that's an imperfection.
You can see in here the lines that he's already made from the sandblasting, and it gets even clearer.
Can you just kind of go forward on that? Because it'll be a while, like I said, it'll be real repetitive. Maybe you can fast forward a little bit on the blasting. Okay.
What type of slag did you say you used for your sandblasting?
I'm sorry?
You mentioned a certain type of slag.
It's actually either a copper slag or a nickel. The product name is Green Diamond or Plain Blast.
Copper or nickel?
And I'm sorry?
Is it copper or nickel?
Yes. And years ago, whenever they were doing the sandblasting, as the term implies, really don't hardly see anybody do it anymore because, the silica sand is very nasty, very dusty, unhealthy for you and stuff. So most people who would have a blast booth who has a place where they do stationary, they even use garnets that are even harder, but they are able to recover and reuse them, which of course we don't have that option stuff out here. And besides, it pulverizes it so to where it would no longer be good to us because it wouldn't give us that 3 mil profile on the metal we're talking about because it would no longer be coarse enough. But as you can see, I mean, it's the way to go. I mean, it'll clean up anything. When you go into diesel tanks, they're just so, such a nasty fuel anyway. You almost have to do this here to even, for me to do an inspection. 2 reasons. You don't have a good visual on it. Secondly, your probe on your ultrasound, you have to use a coupler, and it's already kind of difficult, say on a lining. Your surface smoothness is everything in how well that you can get readings. It's impossible on a tank that's dirty with sediment and everything else on it. So a lot of times we'll have to do just not a complete blast, but one to clean up the tank so you've got a good enough surface to even make contact with your probe or to even be able to see what you're working with. But once they do it, they'll go down the white metal like this here. And of course, the media they use is generally 2 different sizes. You've got like a 16 and a 36, 16 being the larger. That's going to really give it your profile as far as so you can impregnate the metal. Your finer stuff will be picking up and whitening up things around it. But it really, like I said, it's an aggressive deal and it gets it on.
So what he's doing here is grinding down the surface of where there's obviously a perforation in this pipe. Typically he would have done that first, but I don't think they realized it.
Let me correct you on that. This particular pipe they're using, this was actually shoring, 4 foot in diameter that could stack on top of each other. So a lot of these holes were cut there, it was cut with a torch, so there was actually slag that was on the inside that they would have gotten off prior to sandblasting. Because they don't just tackle and start grinding the inside of a tank like that. So therefore he's knocking that slag off so his glass will lay down for him. Because generally you're not going to have slag around your perforation, so that wouldn't be an issue. But unfortunately we didn't think to knock that off prior to them doing it on the pipe, because you can see other ones around their edge and up the wall and stuff there where they had been torched. Now everything from here on will be the way that they do a repair in the tank though.
There he's wiping it down with.
I'm sorry. Yes, sir?
For a leak in the seam where you've got a lap seam and the leak is in the seam, do you have to open that lap joint?
No. What we do there is the seam will be sandblasted all the way around, and the seams, lap seams will always be glassed continually anyway. The reason being is because technically there would be like a conduit up under there. If they only glassed halfway up the tank, those seams would still be open on the top side, which would allow liquid to get behind it and eventually cause a release of your fiberglass. So the seams are completely sealed off by layers of fiberglass mat also. If single wall tanks, if we'd have done that, we could have actually cut the seam if necessary, welded it up and isolated that part. But on double wall tanks, you really can't do any welding because you're taking a chance of burning your secondary and then where you're at while you're pulling it. So the seams are always glassed all the way around to isolate them.
When he was wiping down the inside of that pipe with a rag, he was wiping it down with acetone to partially prep the metal. I don't know if you guys noticed, but it left a bunch of like rag fuzzies and stuff. That was all swept up.
Now, what he's applying here now, this is still just epoxy resin, but it has fillers in it to make it more dense, about like a roofing mastic, so it'll stay put. If you have a perforation overhead, you can put it there without it running or falling out. So that gives them backing to be able to work their mat too, instead of going into making a pocket.
Hi, do you mind if I turn the mic on? It's not.
Yeah, it is. The light's on.
It's not. It's on mute, I think.
I talk pretty loud anyway, so I think.
Is that better? Signal. I mean, if you can use that other handheld.
Okay.
Okay, so as we saw when they were mixing the product, that was the at prime part A and part B. They mixed that together, and now they are applying that to the pipe. Basically, the at prime is a bonding agent. It'll help the fiberglass mat and resin adhere to the metal of the tank. I'm going to go ahead, if you guys don't mind, and fast forward this a little bit just because of where we're at with time. I'd like to have plenty of time for questions and answers. He just goes through, as you can see, the whole tank.
No, actually what he would do, and that's a good question. It's the same way whenever you're spraying liners or what have you. Of course he has the liberty because he has two open ends on this simulation, but he would actually paint himself back to the ladder. And then, of course, you know, you can shift it over and then poke right where the ladder's at, and you step up on it and you come out. But this systems have changed over the years, of course, with technology. This At Prime has actually been a very good product. Once they put it on, it takes about 30 minutes for it to kick off, and it provides a very tacky surface for it to bond to. We've actually compared them to just sandblasting and applying, because when we were first brought onto about this At Prime, of course, you wonder, okay, is this just another gimmick or something? So we actually did our own test. We sandblasted metal, did our fiberglass matting, and we did the At Prime, and then we tried to tear it off, and much better bond. We had good bonds either way, but this was much more difficult to get it to come off.
That chemical mixture there is the resin mixed with the hardener. And
see how he can now stand on it? It's tacky, but he's not leaving footprints.
I don't know that we let that dry 30 minutes.
Yeah, but it's all about heat. So this is outdoors, so don't have the insulation of the ground. So this will actually kick off a bit quicker. Most all of your coatings and stuff, it's not, you can put more hardener in to make it kick off. Heat makes it react. So if you have a nice warm surface, if your material's hot, it's going to start kicking off on you much quicker. And your pot life is always much shorter than it actually is on the working surface.
So there you can see he rolled on the resin, and now he's laying the mat. We use a chop strand mat. Is that what they?
Well, there's a difference. You have fiberglass mat and you have fiberglass cloth. Cloth is just like material in the shirt is woven. You've got strands going in one direction and the other one's going others. This is simulating the same as a chopper gun, where you have hairs going every which way. So it gives you strength in any direction that it can possibly be stressed in. Now you'll notice once they're getting the mat wet, so with the resin, you'll see them go to a different type roller, which will be a steel roller. Almost looks like a bunch of little washers. Even this is what they'll start rolling to actually saturate the mat throughout. and work out any air bubbles. You'll see them doing that here in a moment.
And you can see as he rolls on the resin to the mat, he's trying to get all the air bubbles out even before they go to that other roller. When we repair a patch, we do at least 4 layers for the patch, but then when we fiberglass the bottom portion of the tank and the seams, they do at least 6 layers. In this video, we did I think 3 or 4, I don't remember. But basically it was just unnecessary for the demonstration.
This is 1.5 ounce. Once it's actually saturated with the resin and you get that many layers, you're probably putting somewhere in the neighborhood around a 1/2 inch to 5/8 of an inch of material on there, which is quite substantial. That's basically the thickness of a new fiberglass tank anyway. Plus you have the steel as a backing.
Have you ever done an inspection on one of these tanks? The tanks have been so bad that you in fact would not actually do the repair?
Not on the double wall, but single wall tanks, we, even back to lining, every tank is not a candidate for lining. Of course, we were actually probably more stringent than even the regs down there because we're the ones standing behind them. If we seen that there was, let's say if you only had 5 holes out and it was well without the area it needs to be in, if we didn't feel good about the integrity of the tank, we would condemn it. But we definitely followed by the guidelines because if you can't line something that you don't have the structural integrity thereof. And there's so many times that, you know, insulation of a tank is a big portion. I've seen tanks that are beautiful. Maybe the contractor was short on freshwater sand or pea gravel he's doing and actually dumped a bucket load of the natural soil back in there just to fill it up. You could actually see that part of the tank just gone to crap and the rest of the tank be beautiful. And so soil conditions plays a big part on, and again, that's on the single wall. Double wall tanks, we haven't found one that's been beyond repair for a couple of reasons. Again, it's so isolated where you have the corrosion. Single wall, you had 2 different corrosion aspects working on it, external and internal. So external, you couldn't get there to repair. It is what it is, you know what I mean? So on the double wall tanks, you don't have that issue. You don't have an external corrosion problem. So what you have to deal with is strictly the internal, so you know that you have it managed. Basically, you know, even back when we were doing single wall tanks, if we went to do a tank that was known leaking, the most common thing we found in were gauge stick holes from the days of them doing them with wooden sticks. They would drop and bounce them. I've seen 2-inch holes beat through 1/4 inch steel. And if they have a high water table, I've seen geysers coming up in there 4 or 5 foot, just straight with water. So, you know, there's really on the double wall tanks, anything that they've had that's a problem is well within the repair parameters. Striker plates those are common. Any tank manufacturers, all double wall tanks, you're going to have striker plates under the openings. The single wall tanks, you did not. So they had to be installed. But on double wall tanks, yeah, they're under all the openings that could possibly be used as a fill or whatever.
So this is that other roller that Tom had mentioned where he's working the resin into the mat and rolling out any air bubbles. And you'll see as they go through the process on this, they do that with every new section of mat that they lay. It's also, I don't know if you noticed, but when he pulled it out, it was wet. They keep it in acetone so that the resin...
or it'll keep picking up the mat. So if you see him stop and dip it, that's because he has to, or the roller would be picking it up because it'll become tacky. But as you can see, you see the holes where they were out on the edge, there are white spots. Any air bubble in there would look the same. So as you can see as they're rolling, you don't see any of that in there, so you really work it out. The mat is thoroughly saturated throughout. If it wasn't, you could actually go there and peel it apart. Where it wasn't, if it's dry in the middle, you could just separate it. So it's very important for it to be saturated through and through.
Same procedure for double wall fiberglass.
I'm sorry?
Same procedure.
Absolutely, yes sir, same thing.
That's basically what we're simulating here is what we would do to repair a double wall tank. So as you can see in this step, they're actually patching that little hole that we had. And then once we patch the perforation, then they go back and they preventatively fiberglass the belly of the tank and resin coat the entire tank so that the corrosion isn't an issue in the future.
Yeah, and as she mentioned earlier, whenever you find a known perforated place like that and they do the repair, we'll let that there cure off and actually get a vacuum on the annular to ensure, again, that you have gotten the problem solved before you just start laying mat. We don't really just go in there and lay mat and say, oh, we hope we got it. We actually want to definitely find the issue first. So when these guys would go in the tank, they would do this, the repair here, and before they would actually start doing the rest of the mat layup, they're going to ensure that the tank is tight, and then the rest of it is preventative. Because if you just did that and you went out of it, you're going to have the same problem again. Come back on the areas that are not glass. And the reason why they only go up on the halfway, I mean, you could go in there, the issues are always in the belly of the tank. I don't know if you guys seen earlier when she was showing you dirty tanks where you could actually see definitely two different colors with a line going across. That's basically where somebody's product level stays at. You go in there, you can see where the man keeps his tanks at. The top portion of the tank rarely ever even sees fuel. And you can tell that when you go in there, like I said, it'll be a definite line all the way around where, almost like a soap ring around our tub or something, you know what I mean? You know right where it's at. So the belly of the tank is always the issue. The only time that we've ever found it wasn't, again, it was back in the days of single wall tank, and it was an external corrosion problem. But internal corrosion is in the belly of the tank. That's where all of your sediment is at. That's where you have water at. Like I said, diesel's bad on condensation. You can get a load come in there that doesn't have water, but you will have it eventually. That's, on any diesel engine, there's always two fuel filters. The primary one is a water separator. It's a fact of the fuel. And when you get it in there with the rest of the impurities, it's, and this new sulfur diesel is just attacking them crazy. It really is. So, go ahead and speed up through it.
And the tank is continually being ventilated while it's all?
Absolutely. The first thing that goes on the tank in the mornings is your ventilator, and that's the last thing to come off during the day. We ventilate the tanks through any process. There's, again, that's the first thing in the morning and the last thing comes off in the day, constantly, and along with the monitoring.
I'd like to add to that I don't know if you guys have noticed, but he's also wearing an air purifying mask. That is because the chemicals that they're working with are super pungent.
And Adam will be able to touch on that there a bit for him and actually explain, as opposed to having an air supplied respirator.
Well, it turns out that the stuff they use, the Ad Prime and really the styrene monomer that they have and the other stuff that's in there, this is actually a really big improvement over what they had, say, 5 years ago. This stuff doesn't really off-gas to the extent that the old stuff did. I used to actually have to pull guys out occasionally because it would exceed 5% of the LEL, but this stuff, not the acetone, that part I'm not jazzed about, but the liner stuff itself, the gooey brown stuff, it really doesn't cause us any issues. They wear the respirators because if you've ever been around styrene, even if it's actually fairly low concentration, it is just smelly stuff. So they wear the air purifying respirators, you know, really more for comfort than anything. As far as the acetone goes, not jazzed about that. But the way we get around that being an insurmountable issue is we do it very deliberately. We have a little bit of acetone and a little bit of area being washed at any given time. If you go in there and just go gangbusters and just spill a whole bucket of acetone with a mop, the ventilation can't keep up with that. But the ventilation is able to keep up with a deliberate amount of use. And from what the liners tell me, the repair guys tell me, the fiberglassers, they have to have that to make sure that it's clean enough so that the repair will adhere to the tank. So we do it deliberately, we monitor, and it works out okay, even though I'm not real fond of acetone inside of a confined space.
Yes.
You guys don't stagger your fiber layers?
Yeah, actually, as you'll see them doing it, they're probably got at least a 2 or 3 inch overlap. As it goes on in there, it'll become more defined and you'll be able to see it.
When it dries, you can see it a lot.
Yeah, but they're definitely overlap. And actually, depending on the size of the perforation or however many they're doing it, and again, we did this here Saturday as a simulation there in the yard by the shop. But you keep, if you put down one piece of mat, your next one will be larger than it, and you keep one out, you're overlapping them. So yes, ma'am, that they are. All right. Ask that question there. They're definitely overlapped though.
I'm going to go ahead and fast forward this just a little bit. While we're watching this, are there any other questions on the process or procedures with the fiberglassing operations? Yes. I'm sorry, I can't hear you. Did you guys get that? I can't hear you at all.
Okay, the thickness, you're talking about the metal that's there? Okay, what about the sand?
Do you check the metal thickness after we sandblast?
Actually, again, that's what I was saying earlier. If the surface provides, we'll do the ultrasound prior to it. There's times like in these diesel tanks on them, it's so grody that you have to do at least a partial blast to get it out there for your probe to even make contact and read when you put your coupler. But in the majority of tanks, or say especially line tanks that on single wall, the liner, once it's cured, it's almost like a porcelain. So when you go in there to clean it and rag it up, it's about like doing your sink. It cleans up pretty good. But whenever you're doing these double walls or whatever that is steel, you almost have to do a partial blast just to get the residual off the steel to even be able to get accurate readings. On a line tank, that's generally not an issue because number one, they're much cleaner because of it in there. You don't have the metal reacting with the product, so you don't have near as much sediment in a line tank as you do one that's unlined. So I hope that answered that there. Some tanks you will have to do a partial blast before you can do an ultrasound. It all just depends on what you find when you get in there, how much stuff is actually adhered to the wall.
Did that answer your question? Hold on, I still can't hear you. Hold on.
I'm sorry, ma'am, but I'm serious, I cannot hear you.
So she was referring to a surface profile check.
Okay, well, on the profile check, you get that, there's really no way of measuring it. What it is, they have the, I'm sorry? Okay, you're talking about the profile of the sandblasting, right? Well, that's done through, by the force of the mesh you're doing and the pressure being applied through the blaster. You got to have, the people who we buy the media and stuff from, of course the engineers stuff doing, if you let them know the profile you need and what you're blasting, they will give you the proper grit size and what have you that's going to give you that. As long as you have the compressor back it, which we do. You can't sandblast with a compressor that has a holding tank. These are screw drive compressors that can make air faster than it can ever be used. There's no holding tank that will lower in pressure and up, so your pressure is consistent and constant. It's basically like if you had different grits of sandpaper. Anybody's ever sanded on a piece of wood or furniture, if you got 80 grit, you can see the profile that's cutting into it. And of course, the finer you go, the less that profile is. So just a grit size, and that they know it. By the same token, I'm talking about air pressure. Imagine your hand. The more pressure you put, the deeper you're cutting. So generally, you're blasting about 120 PSI, and that's with a 2-inch hose that reduces down to 1.5 inches and then a 1/2 inch nozzle. So the pressure is very great. If you ever sandblast on one, you can appreciate it because it's a workout. But you know, the guy that's on the end of the hose has a dead man. He controls it. If he was to slip and fall, it's spring loaded, it cuts off. So that's just another safety aspect of it where, also up top, if I need to stop him, I can take the control from him. I could actually make a pot discharge and make him no longer operational down there. So you both have controls over it.
Question?
Yes.
Has there ever been a situation where, say in a single wall diesel tank, the hole has been big enough where you can't degas the tank? In other words, fumes continue to come in the tank, and if so, how did you handle that situation?
Did you get that?
Now, if there was and I apologize, y'all, but I really, probably from years of working in tanks, and I do wear earplugs, but my hearing is
He
really
said,
bad.
have we ever encountered a hole so big that when we're degassing the tank, we can't get the levels down low enough because fumes keep coming out from the annular space?
Okay, no, sir. And one reason being is, number one, of course, they're underground, so any holes that would be there, of course, has soil up against them. And on the contrary, when we're purging or degassing it, let's say, for instance, we're hooked up on the field. We leave the drop tube in, that way that you're getting circulation all the way to the bottom of the tank. We'll go to the opposite end and we'll make another opening, whether that be pulling the submergible pump or opening up the probe riser. So therefore, you're getting circulation. You're drawing in from the top, you're sucking it from the bottom. So you're not only just getting end to end, but you're getting from top to bottom to be able to evacuate all the vapor. Yeah, did that answer it, sir?
Yeah.
Okay.
And I think I'd also like to add to that, the annular alarms go off pretty quickly with any fuel, so I don't think we've ever seen holes like gaping.
Backing up, you know, whenever they say double wall tanks, you actually have two different types. You have a double wall tank, which is literally a tank inside of a tank, and the annular space is pretty great. It's inches and not even consistent. But then you have a double wall tank, which is a jacketed tank. That's a steel tank with a fiberglass wrap over it. Now the annular space in it is very minute. They have a material in between the two that looks basically like aluminum foil. So that is basically the thickness of your annular space. And that's what you see more often nowadays is a jacketed tank as opposed to actually double wall. And that being said, you know, the annular space, you have, whenever it's the jacketed tank, you need very little to actually leak into the annular to actually set off the alarm. Now, on the true double walls where your annular space is greater, you may have to get quite a bit there for it to actually float that. The newer ones on the jacketed tanks, the way that their sensors, it picks up much quicker than it does on a double wall tank.
And this step here, they finished laying all the fiberglass mat that they're going to lay in this demonstration. So once that dried, he's now, I'm not even sure if it's dry actually, but they are now doing the extra top coat of resin. And that typically, obviously we didn't do it in this simulation, but typically that would be over the entire tank. So we would do the fiberglass matting in the bottom, the belly of the tank, and all of the seams, and then we would resin coat the entire tank when we're all finished with that.
Including the top? Does that include the top? The inside?
Yes,
Yeah.
the top.
Even once all of the mat is done, they'll top coat it, resin coat it anyway. That's just take care of any fibers that might have lifted up, whatever. It lays everything back down. And then, of course, the top.
That is open to interpretation, and all of the local regulatory agencies also have the ability to make more stringent requirements as they see fit. So we've come across a few different controversies, as I'm calling them, and it's basically just jurisdictional differences. So when we repair tanks, we patch the perforated area or the corroded area, and then we fiberglass mat the bottom and resin coat the entire tank, just as we went over. So is that a tank repair, as Sessions would refer to it, or is that technically a lining? Title 23 does not actually have a listed definition of a lining, but I did find an API definition, which is a coating bonded to the internal surfaces of a tank to serve as a barrier to corrosion by the contained fluids. So by that definition, it would definitely be considered a lining, which leads me into one of the next slides here. I'm not sure if they're in the order I'd like them to be. No, they're not. Let me find it really quick.
One of the things is, whenever they're talking about a tank being repaired by lining, the majority of tanks, single-wall tanks that were lined, wasn't lined as a repair, they were lined as preventative maintenance. Now, basically, your double-wall tanks, if they were definitely a repair for it. So, you know, it's really, I guess what she's trying to say is, how do you define which was a repair, a lining, or line for an upgrade? You know what I mean?
And it's kind of two different.
They basically still fall in the same one or not, you know? So this is questions we have. We've actually had it where a line tank has become leaking, and okay, does that mean they're still allowed to repair it by lining? Seeing as how the initial lining wasn't done as a repair, but it was done as a maintenance or an upgrade. So these are questions that we still have that come at us, and we truly don't know the correct answer on them either. So we've been hashing that out, and it's still an issue out there because, you know, customers wanting to line it, and a lot of people know it's already been lined, so it's repaired. But the majority of tanks that were lined wasn't lined as a repair. It was they were lined as preventative maintenance for the corrosion.
Let me interject here. So for this slide in particular, we're referring to double-wall tank repairs or leaking double-wall tanks. So one of the things that has been brought to our attention is that technically, yes, we're lining these tanks according to the API definition after we patch the repaired area. So per the Title 23 regulations, are we required to, or would the customer rather, be required to have a special inspector inspect the tanks 10 years after it's technically lined and then every 5 years thereafter? That's something we wouldn't be upset about because it would generate more business. However, that wouldn't make our customers very happy, and also just logically speaking, why does the double wall tank need to be inspected when you've got that annular space, or you know, the secondary containment? So we've already touched on the single wall versus double wall, and our lining inspections necessary for double wall tanks that have been repaired in combination, combined with the fiberglass and resin lining.
Because our take on that, the regs, and this is our opinion, we're not saying that it's right or wrong, this is the way we interpret it, are really leaning towards a single wall tank lining, because you don't have an angular space that's being monitored on them. So therefore, really the only way you have to do it is to go in there and do your inspections. But on a double wall tank, if it's still maintaining its tight, there's no liquid getting into the angular and stuff, we have our customers going, so then why would I have to inspect them the 10 and then 5 years thereafter? And I would say if I was a customer, I would probably have the same questions. But we really don't know the correct way to answer it there, because when I'm reading the regs, it actually is geared more on a single wall line tank as far as that there. I'm not saying that's correct or not, and I've never had nobody to actually clarify that one way or the other, but it's a question that is constantly being presented to us by customers and what have you, and of course us not being people. Some people say, yeah, they have to be inspected 10 years and then every 5 years thereafter, and others don't. So obviously some people out there are interpreting it the same as us, one way or the other. Have any of you guys, maybe you can answer it for us, could answer that?
No, I kind of went down that road prior to the repair that you did for me in Tascadero.
Yeah.
It's like, I don't really interpret what you do, but you showed that video as the tank lining method.
Yeah, see, nor do we.
That was designed to protect a single wall tank. The paradigm at that day was external corrosion, which is why you're measuring wall thickness.
Right.
You can see in some of the slides that you showed with the corrosion where it's perforated the tank, almost like a cavity of a tooth. You're not getting gross corrosion in the tank, but you're getting perforations in the tank. So your wall thickness is still pretty good. So you're doing a tank repair in that case.
that's the way we interpret it.
Also the sunsetting it in 2025.
Right. But again, like I said, it's an issue that is one that we commonly and constantly deal with, but I guess it's not just been unified enough to where everybody's in agreement on what the actual definitions and how they stand on it.
And
because it's a daily issue that we deal with.
one, the next controversy that I want to touch on is the compartmentalized tanks. Generally speaking, when you have a compartmentalized tank, they have different products in each side, so it's not normally an issue. But we did come across a tank very recently that they had the same product in both sides. So is that one compartment or two? You guys can answer that to yourselves. But when we do the repair, we coat the whole bottom half. So if you've got the same product in both sides, as logically speaking, you're going to have a similar result. So if one side's corroded, the other side is probably going to be corroded. And if it's not corroded to the point of leaking, it's probably pretty close if you have the same conditions and the same product.
And again, they share a common annular space. It'd be something totally different if they had their own individual annular spaces on there. But the site she's talking about, they had diesel on both sides. They had one side of it's leaking, the other side's not. It's still the same tank, it just has a bulkhead in the middle. So if this side's leaking, you can pretty much bet that the other side is in the same condition. It's right on the verge. But whenever they have it as a common annular space, in my opinion, the heck with a bulkhead in the middle, the tank needs to be taken care of as a single vessel. But
if it was storing different products, which is typically the case, then hopefully we wouldn't have corrosion on both sides. But in the case that it is storing the same product, that is.
Again, for the regulatory people here, how do you guys address that? Do you do that as a single vessel where it's got a common annular space, or do you still treat that as two individual tanks? Because again, I had this here up in Kern County here a while back, and it was that their deal. We repaired one side, and still had an issue, we still had to go into the other side. It had 87 and premium in them, as far as in there. But again, some people say, no, that's two individual tanks, or it's one. To me, if it's sharing a common annular space, that's one. You know what I mean? Because you can't, yes, sir.
Well, we got a report from the state, we have to count them, so, and many times what's happened is it did have different products and it wasn't selling, or when they learned that they could blend it with the pump, then they said, hey, here's a new compartment.
But because like in my opinion, if you're storing two different products and this animal has two different tanks, and the manufacturers of the tank, in my mind, I don't know why they ever made a common annular space. You know what I mean?
Okay, I'm gonna have to interrupt
if it's actually considered two different tanks holding two different products, it should be monitored for that particular compartment, not the entire thing. But again, that's my opinion. We've had them, went up there, we thought, oh God, now we got to get another permit because it's another tank. But then they go, no, they didn't. They revised it, and we did the other side on the same one because they seen it as one. So we really don't know how you guys are regulating that as a single vessel or two.
Hold on just a minute. Let me get through this last slide. So the last controversy that I want to discuss, it hasn't come up too often, but basically, can the lining on a single wall tank be repaired? So assuming that we enter the tank is structurally sound and it's just the lining that's flaking off because the metal wasn't prepared properly or whatever the case may be, can we repair the lining? As you can see here, I have a couple quotes from Title 23 that says the tank cannot be repaired, but we have been prohibited in the past from repairing the lining when the lining isn't necessarily addressed and the tank isn't necessarily leaking. So that's the end of that question.
Oh, I was just going to say that the state does define those. They have us define it as two separate tanks.
Two separate tanks?
One separate tank 1 and tank 2 in a compartment unit. So,
See, because, and the reason why I question that there is because the site I'm talking about, they decided for us to start off on the 87. because of the tank test, that was the one that they indicated that was getting the product into the annular. So we do the 87, couldn't find anything, made it tight, tried to pull a vacuum on the annular, still couldn't hold it. Opened up the premium side, which was the side they didn't think was an issue. Actually lined it or repaired it the same way we've seen here. We got a tight vacuum on it that held, well, for hours. So therefore, you know, that's what I'm getting at is whenever it doesn't have its own angular space, and it's, in my opinion, it's really a flip of a coin which compartment's actually doing it. Because we banked on the tank tightness test and it was the wrong one. But that was the one that the county says, no, let's do the 87, and I know their reasoning for doing that is because the test results told them to start there. But one ended up, that wasn't the right side, you know what I mean? So it's kind of, I don't know, just a balancing act. In my opinion, when you're dealing with a compartment tank like that, it's really a coin toss on which one it is, because whenever it's manufactured, it's still the same tank. Okay, those there had, okay, 87 and what was it, 89 or 91?
Yeah, 87 and 91.
And to me, that's still gasoline. You know what I mean? Because the actual problem they're having there is not on the octane rating.
Well, we all have to go by what the state says.
No, I understand that. No, likewise. But one of the things we find is there's, I don't know how to say this, and I hope I don't upset anybody, but there's so much inconsistency from county to county, city to city, inspector to inspector on interpretation of stuff of it. And
We see a
I
lot
don't
of
know,
jurisdictional
it's-
differences.
These are issues that we deal with constantly, and I don't know how that could be rectified as far as where it's pretty level across the board, that you know what you're dealing with. Yes, sir.
Obviously, the best way to get consistency is to talk to the water board.
Actually, I've done that. I've actually called in for clarification, with me or against me. It doesn't matter. Just lay it out there.
Just consistent.
And it's hard to get a definitive.
Because
This is it.
there's
Well,
been
at least been my experience.
there's been 2 different tanks that I have been involved in recently where we were not allowed. Well, we could have done the resin coating on the entire tank, but then they would have considered that a lining and required that the customer have it inspected as if it were a lined single wall tank. And so as a contractor standing behind our work, we don't like to only do part of the tank, because then, you know, if the upper half of that tank were to get corroded, we would still in a way be responsible for that. But so it's definitely
costly
difficult.
process anyway, so we try to eliminate not this man having to spend more money back on that same tank again by doing half of it. You know what I mean? So, and that is definitely a repair. But as Pete was saying, that's the way we interpret it.
Before any more people leave, I'd like to thank you all for coming and watching our presentation. Hopefully you guys found it informative and helpful in the future. Feel free, if there are any extra handouts, to take some for any of your friends or coworkers that may have not been able to make it. We will be here for a little while if there are any more questions.
And I hope this did some good.